Welcome back to the OntoTrans Open Workshop. Welcome back to the afternoon session. This morning we gave you an insight and overview of the OntoTrans Open Translation environment, how it works, different parts of it, how it fits together. So this afternoon we're actually going into the translation of the specific cases, and also we'll hear about the benefits that industry is expecting from this type of system from all of our end user companies, which I'm very much looking forward to. To start off with, we'll get an overview of the application cases, the view of the translator from Vinicius Weber from the Fraunhofer IFAM Institute.
Okay, so thanks again for the nice introduction, Gerd. Thanks again for the invitation. And well, today I would like to share some thoughts about the application case, the view of the translator, which has been a work within OntoTrans carried out by a team of translators from the Fraunhofer Institute IFAM and from Composites Evolution. So as a sort of agenda, I will start speaking. I think it was a lot discussed about the translator, who is a translator, then talk about the framework of a translator, which is kind of the things that surround the day-to-day activities of a translator, talk about the 6 translation steps, then talk about the application cases. And from a translator's point of view, how OntoTrans can make my life easier, and then at the end, some conclusions and outlook. So first of all, we talk about a lot of translator, and a translator is someone that, so you have industrial users, also clients that can profit from materials modeling by translated an industrial need and challenge into a solution by means of materials modeling and simulation tools. And then the people, the group of people that carry out, or the experts performing this process of providing a translation service, are called translators. So it's kind of similar to the process of, for me at least, always this we use of this word translation is always connected with language. So speak German and then you translate it to English or to Portuguese or to Spanish or any language. And then this person that makes this transition or this translation of an industrial need and challenge to a materials modeling service is the translator. So the translator can have several roles, can be an engineer, a chemist, a physicist, a modeler, and it can be employed in many other places like the university. I myself work in a research institution, but can be a consulting company and also can be internal translator. So it can be a person that works within the company trying to solve a problem of the company itself. So I talk about in the beginning, so there are three aspects that are related with this work of a translator. So there is this industrial user or the client, there is the industrial need or the challenge, and then there is the material modeling and simulation tools. And let's say for the translator's point of view, there are a lot of different activities which are related. For instance, here is for an external translator. So regarding the industrial user or the client, there is a lot of activities related to the acquisition of clients, the networking, the close contact, the exchange of emails and calls. From the point of view of the defining or this industrial need or this challenge, there is the definition of key performance indicators. There is the technical knowledge that is behind it. There is the business knowledge, which is also related. And then from a point of view of the materials modeling and the simulations tools, there are the contact with software suppliers, up to date with new methods. For instance, nowadays there is a lot of work with machine learning or artificial intelligence. There are these different activities which are related with the work of a translator. So there are the industrial user, the industrial need, and the materials modeling and simulation tools. So again, there is a lot of other activities that need to be done within a translation service, which require the involvement, this directly or direct or indirect, of the translator. So there is a perspective of project acquisition. So if there is no project, there is no money, there is no translation. And this involves, for instance, like advertising or networking. There were a lot of work related to NDA signing and the definition of data sharing with your client. So basically no contract, no money, no translation. And there is also the procurement of equipments and consumables, etc. So in idea, so there is no results, no money, no translation. So there's a lot of these topics that will not be covered by today's presentation, but are nonetheless essential within the day-to-day work of a translator. And this, let's say, the solution finding process involves a lot of exchange between, for instance, like an R&D project manager and a manufacturer to find the different types of data and to define the missing data, to see which is the missing data, what can be, how this data can be acquired, and also to have a proper evaluation of the available data. So again, this process is translating an industrial need into a solution, involves translating an industrial need into an innovation challenge, then a case-wise translation and innovation challenge into a workflow, and then translating a workflow into a solution. As my colleague this morning, Michael Nuska, presented today, so this process of exchange between the translator and the client, or involves, let's say, a process that are two persons looking at the same thing and having different types of observations, which is related with their background, and at the end finding, let's say, a proper communication and finding a common language or an agreed language in which they can work together. So again, the client, he or she or they want to solve a challenge, wants to improve a process, wants to make something new, wants to make something faster, and sometimes wants to make something new faster. And the translator has to provide a solution. And however, the translation by their own with on the knowledge, the translator is limited within a framework which is related with his knowledge background, with the research facility of its employer, and also the software available or the license in which, in this case, by their own, I mean without OntoTrans. And let's say that the framework of the translator, for instance, if we are talking about a translation service dealing with composites material, right? So from the translator perspective, there are a lot of limiting stuff, which they're the data availability, the neutrality, the translation budget, because also there is a lot of the budget which is involved. So depending on the budget available for the translation, you can offer different types of solutions. So for instance, from my background, I'm a mechanical engineer, but I have with the years worked a lot with material science, but there is a lot of different knowledges, for instance, chemistry, physics, and data science. So it's very hard, or sometimes there are people that have all the background, a very large background, but usually we are, like translators have specific set of skills or knowledges. There's also sort of software availability. So not every company has access to every possible solutions in terms of software. And this is also a limiting factor for the work of a translator. There is also the testing facilities. So if you need material properties, there are several types of characterization methods that not necessarily the translator would have access to. I give an example here. So among all these different types of testing facilities, you might have access to 1, 2, or 3 of them. And there's a lot of other techniques that the translator would not have access. And also in the specific case of composite materials, there are a lot of manufacturing methods which the translator does not necessarily have access to. And again, also a very important thing, there is the data interoperability between client and translator. So sometimes the type of data, the client will work with a certain software, the translator will work with a different type of software, and sometimes these types of the softwares will not be interoperable. So this is also a limiting factor for the translator. So, and a possibility of expanding this framework is the cooperation with other institutions. For instance, if you have 3 institutions working in a translation process together, then you can have institution 1, which would be specialized on surface characterization. They do have a lot of different methods. for instance, for surface characterization. Then you have a second institution, which is also related to, this is something that also we do in European projects, for instance. Then you have institution number 2, which is specialized on mechanical testing, for instance. We have all the necessary testing for mechanical testing. And then you have a third institution that will provide the manufacturing aspect of the translation service. And also within this, you also always have the limitations of data availability and also the translation budget. So in the case of the background, you can have a team of translation. So there is some examples here. You have a translator number 1 would be, let's say, the engineer, which would be something specialized in materials mechanical testing, materials manufacturing. There will be one, the chemist, which would be someone who is specialized on formulation, surface characterization. Would be the data scientist, which is someone with is an ontology expert or an artificial intelligence expert. There is also a person which is the simulator, for instance, that would be, will help on the workflow definition and finite element analysis. And again, all this is linked to the data availability and translation budget. So fortunately, there is a guide to help translators on how to proceed with translation and make this easier to make the translator bring benefit to the clients. So we talk a lot about today about these 6, the translation steps according to the MMC. So I'll go through them with a more example here. So there are the 6 steps, and which is important to say that this translation steps and that translation is an iterative process. Translation might involve a team of translators, like the example that we are giving today. The translator will not necessarily be involved in all steps. Sometimes the translator will be involved on steps 1, 2, and 3, and then the steps 5 and 6 will be done with another team, or will be done within the client. So there is constant communication with the clients, and it's very important to be very clear alignment of scope, budget, and timeline or the schedule. So very important aspects of the translation steps is that neutrality is very important. So the neutrality here is expressed by placing the specific interest of the client always before the transparent interest of the translation. So the translator can be a part of the modeling execution if this is of benefit of the client. And also the translator should advise the client or the end user in the decision making based on the modeling results using business relevant data. So there is always this aspect of business within. So there's, let's say, the technical part, but there is also a business aspect, and confidentiality and trust between translator and client are very, very important. So the idea of the translator is someone that you have this knowledge from the business part, and then you, let's say, from the business aspect of it and to the modeling aspect of it. So within OntoTrans, there are 4 innovation challenges. So one is the post-launch analysis of pouch detergents. There are the detergent pouch systems. There are the composite prepregs, and there are the steel section mill. So 4 very specific challenges, and each one has a specific aim. I will today talk more specifically about the composites prepreg. The aim is to achieve improved understanding, ultimately control of the process to reduce time and costs in development and manufacturing. So again, bring me how it works. So within OntoTrans, there were the team of OntoTrans experts, which were external translators, and then the team of the Prepreg manufacturer, which is the client. And the challenge here was to achieve improved understanding and ultimately control of the process to reduce time and costs in development and manufacturing. So the first step is the good understanding of the business case. So understanding the business case, we realize that market, regulatory, and safety requirements drive the transition towards non-toxic, low environmental impact solutions for composites prepregs. And innovative prepregs provide a potential solution for this, let's say, market need nowadays. And then translators' questions in this step can be, for instance, what are the KPIs? What are the expected benefits for my client, and in which are the standards, norms, and laws involved? For instance, GDPR regarding, in Germany, for instance, regarding the sharing of data, and also ISOs, etc., etc. And then the KPI definition, it's usually an interaction between external translator and client. So there is, for instance, a large list of potential KPIs. And according to the client, the idea was, let's say, they improve understanding and control of process, improve quality of end products, reduce development time and costs, and create a model-based approach for future product developments. And after the interaction between the external translator and client, then let's say two cases were defined. One case, the input is new process parameters like temperature, pressure, and geometry, and the output would be expected mechanical properties. And the other case would be to input required mechanical properties and as an output get suitable process parameters. And then as a KPIs, let's say it's measurable KPIs, there is the time to market, there is the number of tries until a product is obtained, and the mechanical performance. In this case, there are two properties, which is the interlaminar shear strength and the tensile strength. Again, a good understanding of the industrial case. So it was to understand how the process of the innovative prepregs work in practice. So let's say the process was divided in three, let's say, sub activities, which is the resin preparation, the prepregging, and the composite manufacturing. And then two of these activities were done within the client, and the third step was done at the end user. So it's kind of a client's client. And the translation questions in this step is how the manufacturing process is carried out, how to control it, which parameters have an influence. And then in this step, it's very important to understand how the process actually works. So for instance, here, just an example, one needs to understand that a prepreg is formed using a resin and a textile fabric. It has certain anisotropic properties, then it has one layer, then afterwards the prepreg roll is cut, then it's stacked, and then afterwards there is a process of molding and curing. And now again, the very important step is step 3 is the analysis of the experimental and modeling data available within the client. Let's say that here there are 3 groups of data. So there is the client's proprietary data, which is data that only the client has access to, and then it gives to the translators. And then there's always some sort of NDA or data sharing policy behind it. So for instance, internal measurements of viscosity, the resin formulation, which is kind of industrial secret, the tools geometry, manufacturing price, which is all data that is internal or is proprietary to the client. Then there is also publicly available data, for instance, the product data sheet, which is something that is available to everyone, that contains information like mechanical properties, fiber content, density, the product sell price. And there is also additional data, for instance, benchmark values. So for other competitors of the clients, and then reference values of mechanical properties, for instance, that one can find in materials databases, etc. And then all of these different types of data, there is let's say a work behind regarding the data itself, data format, interpretability, metadata. And then at this step, there's a lot of questions regarding, is the available data fair? Let's say findable, accessible, interoperable, and reusable. Will I need extra experiments or characterization for additional simulation parameters? Can I get more data from an external repository? So do I have all the data necessary to carry out the translation? A very, very, as I mentioned before, a very, very complex case or thing that occurs often is the problems with data interoperability. For instance, this is a practical example. So it's very common that the client creates parts, geometry. So it's the geometry of a part with a specific software that has proprietary file format. Like you have, for instance, ANSYS, Pro Engineering, CATIA, which are, let's say, commercial softwares. Then afterwards, the translator needs the geometry of the part as an input for an finite element analysis, which can be done with hypermesh abacus, which does not necessarily communicates, i.e. it's not interoperable within the original software. And then there are open file formats, for instance, like step files, which are common to most softwares, but usually many features here are sort of lost in translation. So there's a lot of features, a lot of information that when going from one software to the other is lost. So, and then what happens, many cases, in the worst case scenario, the translator has to build the geometry representation from scratch. So it has to take the file of the client and then do it once again, which takes a lot of time. Also, there is a lot of issues regarding missing data or missing information. So during the translation process, it's usual that in order to carry out a workflow, some properties or parameters required for the simulation are not necessarily available. So potential solutions, one is to carry out experiments by the translator or in an external provider to obtain the missing data. You can use materials modeling to obtain the missing data. For instance, use molecular dynamics to determine the Young's modulus for a finite element analysis. There is a possibility to find the missing parameter on industrial data space or a parameter repository, or is it possible to guess or assume the value of the missing parameter based on reference value? So there is always some kind of relationship, and then you assume a certain value, but this could lead to a reduced confidence interval in terms of statistics. For instance, again, so after agreement between client and external translation, this is a model representation of the workflow. This is one case. So the input are the manufacturing steps, temperature, pressure, geometry. There is model one, the raw output. Then we have the first KPI, and then we would use the output one as an input for the input two. There is a second model, and then at the end there is the expected mechanical properties, which was the KPI two. And then the translation questions in this step are: is every data available? What happens if one of the link between model is broken? So what happens if there is a problem with my first model, which are the contingency plan with some data is missing? Then one can say that if the model is missing, then you can do like an experiment to let's say overcome this limitation. Then step 5 is to propose to the client modeling executors and strategy for model validation. Then let's say the plan is the translator executes the workflow using materials modeling. Client provides a prepreg for manufacturing. The translator acts as a surrogate of a client's end user. The translator manufactures composite laminate with client's prepreg. Translator tests the composite laminate. Translator and client discuss the KPIs, and the process goes on until a solution that is good for the client is obtained. Then the translation question in this step are: is there an alternative model validation? Is the validation broad enough to cover all aspects of the manufacturing? And finally, translation of the 6-step translation of the modeling results to information that understandable, reliable, and usable to the client. So for instance, in this case, the simulation, modeling, and testing. So if you see here, the simulation is the same geometry of the testing using manufacturing, and then the manufacturing as well. So there's the manufacturing, the testing, and the simulation, and then a validation between testing and simulation. And then at this step, translation question might be how to present the results and how to make the results reusable to my clients. What happens if the client changes one of the resin or changes the prepreg? What would happen? So again, as I spoke in the beginning, so how, from a translator's point of view, how OntoTrans make lives easier? There's a lot of activities that need to be done of a translation. For instance, there is the acquisition of clients or acquisition of projects using the OntoTrans open translation environment. The OntoTrans provide interface with marketplaces, what helps translator finding clients or acquiring projects. Then there is this very important step: define suitable KPIs. Then OntoTrans has interface with business decision support systems. There is also ontological specification. Then finding missing data. OntoTrans provides OntoKB and the exploratory search system. Again, guidance during translation. Then there are this OntoTrans has app-specific GUIs. There's also the recommendation system. And also a very important step is also running simulation itself, which is provided by the interface with open simulation platforms. So as a conclusion and outlook, the translator of a team of translator provides service of translating an industrial challenge into a solution by means of materials modeling simulation tools. And translation involves activities covering NDA signing on data sharing to simulation. And translators can be either internal or external. and that the translator is sort of limited by a framework since it's not possible to provide all available simulation, characterization, and manufacturing services. The MMC6 translation steps provide a structured pathway for the translation process, and within OntoTrans, the 6 steps are being followed within 4 application cases. And let's say that OntoTrans provides an environment that can expand the translations framework in steps and activities such as support through acquisition of projects, definition of KPIs, finding missing data, and running of workflows. So this is the talk for today. Thanks a lot for your attention, and if there are questions, I'm open.
We're now going to the final presentation, which is really a number of presentations and hopefully, a bit of interaction with the industrial users about the OntoTrans benefits for industry. We have Alex Simpeler. Hello, Alex.
Okay, good. So welcome you to the last but most exciting session, of course, with OntoTrans benefits for industry. And we explain a bit why we do benefits and why and how. And then I'll show you a bit of a benefit dependency network, and we will listen to our industrial partners. So they all will come on board and tell you about how they see it. So who are we? So as we can't see each other in real life and all sessions still are virtual, I'm working together with Gerhard Goldbeck in surprisingly Goldbeck Consulting. And we do a lot of things, and you know us from different perspectives. And here in this particular work package, we look after benefits management. And it's another way for us to bridge how a new tool, mainly software related, can enter into an organization. So let's talk benefits. This is why we're here. So the idea is of bringing a new thing to your company. That means you will be doing things differently. It's a new thing. It requires different things. And what we try to get over to you is that you will be stop doing things, but that means you have time for other things, or maybe you start doing new things. Okay, so this is what we want to get. And now we have to think about, now what's the new thing? In our case, it's a tangible product, a tool, it's OntoTrans. So OntoTrans is the new thing that in some ways will enter your organization. And now we have to discuss the enabler versus the benefit. So for example, if you do your baking in the old-fashioned way with your stirring bowl, you could get a mixer. So this is your enabler. So it's a thing that makes something possible. So less stirring, you get more done, have time for other things. And then the benefit comes in, which is then an advantage or profit gained from something. So we shouldn't call, must not call even our new thing a benefit, it's an enabler. And for each enabler, then we work out its advantage or profit. And when we do this in Goldbeck Consulting, we do this together and always have the discussion, is it an enabler benefit? So it's a good way when you bring them in to discuss them. A new thing comes with changes. So when I bring this to you, people will have a new job role. They will have to do some upskilling. Teams need to form in a different way and so forth. I don't want to mention raise your head count. That's not going down too well with some organizations. Tools are, we have new software, new databases, new hardware, new products. We have to change the process because maybe if I was a product or project manager, I suddenly have to change my style a bit. Digitalization comes in. I want to catch up with Industry 5.0 and so on. And usually when we come with something new, data will change, and it does already. So we go from analog data to digital data. For OntoTrans, we need to look into metadata, into semantics, into ontologies, new concepts, data commons, for example, to share stuff and so forth. So a lot of change is going to come. So when I give you the change now, I will discuss with you the advantages, what's in for you if the time for change comes. I will tell you it makes you more contemporary. it caters for new job specs, and it brings you closer to Industry 5.0. But you will need to let me in. You need to let it happen. And the disadvantage is it will cost you time, money, people, and resources. It does not come for free. We work a lot with ideas by Peter Ferdinand Drucker, who was an Austrian management consultant who did his work mainly in the States. And he also coined and worked around the knowledge worker. This is what most of us are. So I will bring in doing the right thing is more important than doing the thing right. And you will see when our three colleagues from industry come on stage, they certainly are doing the thing right, no doubt about this. But we want to add them do the right thing, because if you want something new, you have to stop doing something old or still get going, but do it in a different way. So this is what we want to bring to them. And here I show you a simple benefits dependency network, which we adapted from Ward and Daniel, a book they wrote by 2006, where they introduced this. So you can see the new thing is an enabler. And then the orange bit is the crucial one, because this is the enabling changes I need in your organizations. We need to do something with the staff, with your established tools, with the processes, with the existing data. And then comes the green bit. I say, okay, your business is going to change. And then you can reap the benefits. This is what we want. And what we really come in, please meet your benefits dependency network. Everything is a result of combined changes. So go back to the orange bit. I bring the new tool, which is OntoTrans. Okay. So then the enabling changes you need to give me is train your staff, or let me train your staff. Hire a modeler. Does your hardware fit? Do I need software and services? Do you need to purchase something? You have existing tools. How can we interface? Your R&D process will need to adapt, digitize maybe. And we need some sort of semantic data storage. So we know about this because OntoTrans has OntoIn, needs something semantic. And now you realize when we go into the business changes, why this effort is worth it. You get many more errors, as you can see immediately. So if I enable a change, more things change. There's a combination going on. So you start to profit already, because now you can see my company is doing modeling. Yeah, I'm digitized everything. Suddenly I can combine data sources, and yes, my existing processes are enhanced. And by doing so, we then reap the benefits. Faster time to market, less waste because I can model, faster response to manufacturing challenges. My products are even more cutting edge. And then data and knowledge finding process becomes fair. That's very important, because not only data fairness we know, but if I know how I found the knowledge, why I found the knowledge, can I use the knowledge, it's a different game. And then, of course, data valorization and data value generation. And can you check if the benefits you get meet your objective? Yes, you can. So there will be some objective you get from the outer world. Let's say the Green Deal that comes in from the European Union. And also your visions, because maybe your company wants to be innovative. That's an objective. Then you can see, hey, the benefits exactly do what I promised. And also nowadays response to society's needs, so we can fulfill our objectives. This is enough from me to actually talk about benefits. So we want to hear from our colleagues from industry what's going on. And you have heard them mentioned throughout the day. So they are our testers. They are doing user requirements with us. They give us ideas. They give us insights in how their company works. So they give advice, they test, they want, and they're still smiling. So that's an advantage. Yeah. And I shall introduce to you Lucy Bull. She is the project manager in Composites Evolution. And she will show you that indeed to her company's name, there is evolvement going on, because they will evolve with OntoTrans now. Then we hear from Diego Diaz Fidalgo, who is a global R&D expert in artificial intelligence. And he will say, okay, what is ArcelorMittal doing? And we'll see some benefits from here. And finally, we have Oreste Todini, a research fellow at Procter & Gamble, working in Brussels. And I can tell you, after his talk, when you put a washing pot in your laundry, you will never see and look at them in the same way again. So this is me done, and I will happily hand over to my colleagues.
Yes, good afternoon, and thank you for inviting me to talk. I'll just get my tabs all in order. Yes, good afternoon. My name is Lucy, and I'm here to present an end user or client perspective of OntoTrans and how it can have a positive impact on the innovation process. I am the project manager at Composites Evolution, and as you've probably gathered now, we're one of the end users in the OntoTrans project. We are a company based in the UK, and we develop, manufacture and supply composite prepregs to our customers, who then mould and cure these to form finished composite parts. As well as the production facilities that you see in the photos here, we also have pilot scale facilities for short runs and a team of experts and development engineers who provide technical support in the form of in-house prepreg development and testing. And for those of you who are still not quite sure what a prepreg is, I'm sure you're not alone with the people here at this meeting. Prepreg is basically fibres which are pre-impregnated with resin, and the resin is staged or very partially cured to make it easy to handle. To prevent the prepreg from fully curing, it's stored in a freezer until it's time to make a component from the prepreg. So rather than using loose fibres and a sticky resin, which is very messy and difficult to control, our prepreg arrives on a roll with very consistent properties. Once a roll is thawed out, our customers then cut layers from them and will place these layers in a mould, and then the mould will be cured either in a press or an oven or an autoclave to form lightweight, high performance components for use in aerospace and motorsport, something such as this car spoiler here. So innovation to us can mean a wide range of things. It could be challenge solving, for example, a customer complaint or an internal non-conformance where the material doesn't look or react or behave quite as expected. It could mean improvements to processes at our customers, so improving cure cycles, press parameters to improve quality, things like surface finish, reducing porosity. Or it could be modifications to cure cycles to increase productivity and throughput. A large area of our innovations are in relation to new products. So if we wanted to include new materials such as new reinforcement materials, reformulated resins, if we want to include some additives to improve certain properties such as flame retardants or conductivity, for example, or more significantly recently is the incorporation of more bio-based or recycled materials. But another area of innovation could be improving our own efficiency, manufacturing prepregs, increasing the line speed, impregnating heavier fabrics, which means that our customers would need to use fewer plies to achieve a certain component thickness, or it could be something as simple as improving energy efficiency or reducing waste and offcuts. But ultimately, Vinicius put it very well, we are looking to make something new faster. So we have what I think is quite a good approach to new product introductions, but without materials modelling or a data-driven approach such as OntoTrans, the development stage can still be very time-consuming. So I'd like you to consider us looking at a new base resin, for example. Currently, without OntoTrans, we would start by looking at the chemistry and resin formulation, and then we'd need to do some small-scale mixing trials to manufacture small quantities of resin to test the thermal properties, the viscosity, the reactivity, to see if it's compatible with cure cycles used by our customers. The next step would be to make a small amount of prepreg, which we might lay up by hand. and then we'd test the prepreg for how sticky it is, the outlife, how long it remains usable at room temperature, resin content, etc. And if anything wasn't right at this stage, we'd have to go back a step. If it was good, we'd then upscale to pilot line, go through the same set of testing, but we'd also then cure some panels and test mechanical properties. And then again, if that didn't work as expected, we'd go back a step. If it worked, we'd then upscale again to the production line. And only then, if we're able to prove the process at this stage, would be ready to verify the new product with selected customers. So obviously this is very costly and time consuming and slow, even with good procedures in place and a knowledgeable technical team. And this is where OntoTrans approach comes in. OntoTrans requires an industrial need or challenge, or an innovation case, if you like, such as reducing the porosity of composites made from our prepregs. It needs translators who could either be trained, a trained member of Composites Evolution, or an external translator, someone that we would subcontract to. And OntoTrans needs good data and integration. And this leads to improved workflows to predict porosity based on certain input data, or it could be a prediction of the input data based on the resultant porosity. So, for example, an end user may present us with a challenge, such as an image of a composite with voids present. And then with OntoTrans, the translator could perform quantitative image evaluation through an app, such as the one being developed at IFAM. And we could offer data-based feedback very rapidly with very little or even no practical work required. And this offers clear benefits, increasing the efficiency both of reaching this level of understanding through decreasing the development cycle, but also in improving the efficiency of the manufacturing process as a whole. So what do we as an end user expect from OntoTrans? The following are the KPIs that we shared with IFAM earlier in the project. We want to improve our understanding and control of the process. We want to improve the quality of our end products, and we want to reduce development time and costs. So using a data or model-based development stage to rapidly identify key input parameters that might require further physical testing, or effectively a virtual design of experiments. And to create model-based approach for future product developments and individual process optimization for product users. But we also have some other expectations. We currently are an SME without in-house modeling expertise, so we would like a user-friendly GUI interface or translator tools that are easily accessible to development engineers and technicians. We'd like to foster objective communication involving data-based feedback of user experience. And ultimately, we want the ability to be more responsive and adaptable to our customers' requirements. Thank you very much for your time.
Okay, so thanks to Lucy for this, and our next speaker will be Diego.
All right. So my name is Diego Diaz. I'm a researcher in ArcelorMittal, in particular in the digitalization team that we have in our research center in Spain. So ArcelorMittal is one of the partners in OntoTrans, once again with an industrial case, just like the one we have just seen. And well, for those of you who don't know, ArcelorMittal is the largest steel producer and also I think it's fifth largest iron ore miner in the world. I don't think it's necessary to explain what steel is. So in our case, in one of the many steps needed for the production of steel, we're focusing on a line where we produce beams like the ones that are used in buildings. We are aiming at improving our ability to, let's say, make these BIMs in the best way possible. So the main idea of our use case is to find what is the best setup, the best process parameters to make sure that we are reaching the properties of the steel that our customers require, and this could be quite exacting. So the benefits that we get from this use case is basically facilitating the access to the data and also the ability to make this data that we have more discoverable. It's something that I would say it's quite common in very large companies, and especially in relatively traditional ones like the steel industry. That the data sources are very widespread data in different databases managed by different levels of IT and different departments and so on. So that's usually one of the initial hurdles that we have to go through. Then it's also the advanced modeling to be able to first predict the material properties from the process parameters, and then put that through an optimization loop so that we can find out what is the best way to actually set up the line for the production. And if we have that, what we can do is when we have a new product, when we have something that we need to adapt, when we build a new line, we can do these adjustments in the digital space, which means that we can have fewer physical iterations. This gives us a faster time to market, and also obviously a cheaper way to reach the ability to make the new product. Okay. So those would be the specific benefits of the use case, but the concept of the development of the use case is actually quite general, in the sense that we can take this idea of having the data in a way that is more readily discoverable, that is more easy to access, that is there ready for us, but also with the semantic component that was mentioned before, which means that it's also easier to integrate with different algorithms, different methods, and so on, which means that it becomes easier also when it comes the time to develop these kind of let's say use cases, the different models that we build by just combining these elements rather than having to work very specifically for each one. So building on this idea, the situation that we have, as I said, is relatively spread out data sources with different layouts and different ways of storing the information. Things that should be similar, maybe in different places, called in different ways, and accessible in very different manners. And we get one model that we want to develop, something like the use case we have now in mind. Sorry. And what we have to do is to build a system to access that specific data, make an extraction, process it appropriately, and develop an algorithm that works with that to get the results. Okay. And for this, of course, we have very good competencies. It's something that we have developed many times for very different use cases. But when we get the next model or the next project that we want to develop, we're basically doing the same thing again. Even if there is some overlap, it's normally something that comes quite distinct, then you have to develop it quite apart. And then when you have another one, even if it's really close to the first one, it's a kind of an adaptation or an evolution. Still, it's very difficult to reuse something that is so specific, and you end up having many different modules. You have a larger burden of maintenance. You have to maintain all of this, and the interactions among all of these elements start to grow. And we see what OntoTrans proposes as a potential framework to reach a more organized way of doing this, in which the data is organized in a way that it's easier to understand. It's easier to get to it independently on where it is actually residing or how it was obtained. We can expect the same thing at the level of the algorithms, and that applies to the ones that we can develop, and we can make them more generic, since it will be much easier to connect to the information and the data, but also to potentially external providers of algorithms. It will this would make it easier to integrate outside solutions in there, and then building the solution for each of the potential use cases that we may have is a matter of combining these resources. So we would be working at let's say a higher level of abstraction than we are doing now, which would allow faster developments, having more solutions, and obviously that leads to tackling on more complex problems to solve. So the setup of this specific line is the use case that we have brought to the project, but we can see many more potential areas of application for this kind of approach, and it all in the end meshes together. So if we consider this in a way kind of starting up a digital twin of the line, then that expands into things like scheduling. What is the way you process the different products so that you can get the best productivity while meeting the quality constraints. You can think also of the digital twin of the product, and understanding whether you're getting the quality that you need just from analyzing the information of the line parameters as the product is going through it, rather than having to wait and maybe do a physical test later on, which means that you can have that level of assurance for every item that leaves your line, rather than having to do some sampling. There's predictive maintenance, which is something that we all have heard about, and then this kind of approaches would also link to other high level systems. So you can think on connecting these more production oriented models to the commercial systems, to understand what is the capacity that you have, so that the commercial systems know what they can offer when there is a request, or what is the date by when you can promise a specific product. All of that has to be integrated with changing the planning of the whole plant, not just the specific line that we're looking at right now, and so on. And all of this requires a very high level of organization and interoperability. What we saw before is that in the current state, there would be a tangle of individual solutions, and the number of interconnections of those grows exponentially. By having something like OntoTrans as a foundation to have a more organized approach, uh, both in the technical side and on the security side, uh, it will enable us to reach this kind of situation, and to be able to develop all these kind of systems in the future, which is something that would be much more difficult to do with the current situation. Thank you for your attention.
Brilliant. So you see the benefits are coming in, and we want to hear more benefits from Oreste next. And I tell you, it will be a true live podcast.
Okay, I'll move to the first slide. So my name is Oreste Todini. I'm in Procter & Gamble. One of the the consumer products we produce is the soluble unit dose detergents, also known as pods. You see a picture of a design of this type of products. Those are really multiple formulation in one, wrapped by a water-soluble film, which one tossed into the washing machine will dissolve and release the chemistry, and so provide the cleaning, softness, whiteness benefit. This is a fast-growing consumer product segment. Europe is a key market, and it's a complex formulation structure, as you can imagine. Each compartment can contain between 20 and 25 materials. It's also, because it's a water-soluble film, of course, the formulation needs to be very low in water content to maintain the stability before usage, and then of course dissolve fast during the wash, so to release the chemistry and deliver the expected benefit. So what are really the benefits that we expect from an ontology framework? And I'll concentrate on the green box. One important area is really, of course, a common knowledge basis, but also the democratization of the data and modeling access. As you will see, the two applications really operate at the boundary between R&D, marketing, product supply, which are different functions within the Procter & Gamble organization. And so democratizing the data means making available these type of tools not only to an expert R&D community, but to a broader organization. And so being able to leverage data and models across the whole entire product development cycle, from the design of the formula to the assessment of the consumer response to the product supply, so the production and distribution of the products, but also to understand what happens in the market once the product has been launched. In the first user case, what we are looking at is a post-launch analysis of detergent pouch. Once a product has been defined and is being introduced in the market, we typically do collect data about the sales volume across different retailers, across the different countries in which the product is marketed. And these data are very important to define whether the success of the initiative, whether the type of support we give to the initiative, the size, the product attributes are really delighting the consumers as we would expect. We typically acquire these data sets through third parties, or directly from the different retailers. And so the objective is to use machine learning and database mining to really understand whether what is the initiative success. And the more this type of assessment is done in real time, of course, the more beneficial it is to have any correction actions to make sure that we are offering the best product possible lineup to the consumer. In today at P&G, we monitor these the initiative success, as I was mentioning, through the acquisition and the analysis of sales and data collected by third parties. And we typically use control charts to understand what is the variation of the sales volume versus the expected trend. What we expect is that the ontology coupled with machine learning provides an acceleration of this analysis, so that makes it it gives insights that are more actionable to intervene whenever necessary to correct the in-market dynamics and make sure that we have the best possible product lineup in the market. In the second application, we are actually looking at the development cycle of this detergent pouch system. And the objective is to have a more integrated digital work process, which is consumer-centric. It's very important, this aspect, because really the consumer is at the center of the development. The products need to meet the consumer demand and needs. And because the product is relatively complex, there are, of course, important consumer satisfaction and purchasing drivers, which are related to the product's performance and product attributes in general. But also, there are a set of constraints that need to be always met that concern the product processability, safety, sustainability, the carbon footprint associated with the product, not only with its production, but also with its usage during the washing cycle, during the cleaning cycle. And that's very important. Actually, in the products, if we look at the total carbon footprint, actually the wash cycle is very important. And washing in cold water, which is actually one of the features that we want to push more and more to improve the sustainability of the product, has a very important impact on the carbon footprint of detergent products. So washing in cold and short cycle is actually very beneficial in terms of the carbon footprint of this type of products. So today at P&G, we already leverage a digital design work process. So we do design virtually and we confirm experimentally that the product have all the right characteristic and the desired features to meet the consumer demand. But we expect ontology to further enhance this capability, again, through an acceleration of the development cycle, but also to democratize the accessibility of the data models and tools to a broader non-technical organization. Procter & Gamble is a relatively large organization. And of course, in all large organizations, you have different degree of technical skills. And in our experience, it's extremely important the easy to use of digital interface, the natural interaction with this to foster the adoption of the digital tools. And the adoption of the digital tools is directly linked to the business value that they deliver, because the more they are used, the more they provide benefits to the broader organization. So we really count on ontology and the OntoTrans program in this specific area, which is the democratization and accessibility of the digital tools. And with this, I have finished. Thank you.
Okay, thank you very much. So to summarize our little session, it was all about to bring to you that OntoTrans is an enabler, show our industrial partners with the already excellent workflows and ideas, and how from their perspective you can expect benefits with together, and we are co-creating this. So our industrial partners are also co-creators, so we're an open innovation environment, and we hope we have whetted your appetite to hear more and see more of us. Okay, and with this I would kindly hand back to our chairman.
Thank you very much, Alex. Thanks, Lucy, Diego, and Oreste. And so thank you again, everyone. Hello, Nadia.
Hi.
Final
I
sessions.
just wanted to join at the end to thank to all speakers today for presentations and for presenting the project approach and the current status on results that we achieved so far. So thanks a lot from my side to all of you. And with this, I would like to conclude the first day of the workshop and have a good evening. Goodbye.